Welcome back to Program Logic and Design. In this chapter, we're going to be discussing making decisions and decision structures. In this section, we're going to be discussing Boolean expressions and the selection structure. Now, to understand the Boolean expressions and the selection structure, we need to have an understanding of the biography of George Boole and who he was. Now, George Boole was a great man with no formal education and was a ferocious, when I say ferocious, I mean he was a hungry and greedy reader. Now, he founded logical Boolean expressions, and the Boole's two-valued logic, which was true or false, lent itself to a description of electrical switching circuit, which you guys already know as binary code, which is our zeros and ones. He also founded the invariant theory, which later inspired Albert Einstein. Now, he also helped with the development of calculus and differential equations, and much of the new maths, which is studied today by school children, stems from Boole's work. Now, in 1849, he was appointed as Professor of Mathematics. Now, it's not so bad for a man who had little or no formal secondary education and no degree at all. Boole's two-valued logic was true or false. He said that basically most expressions can either be true or false, and every computer decision yields a true or false, a yes or no, 1 or 0 result. Now, this type of evaluation is natural for a computer because via electrical circuit, our switching is either from 1 to 0. Boolean expressions are used in every selection structure. So let's take our dual alternative or binary selections. As discussed in our previous sections, is that it provides an action with two possible outcomes. And it is always our if-then-else structure if we were working in our pseudocode. Our single alternative structure, our unary selection structure, is action provide for one outcome. And it is in pseudocode, it is if-then. I wonder if you guys can remember what this case over here was. Yes, a null case. So what's going to happen is if it is false, we just carry on with our program. In your textbook, you are given quick reference 4.0 if statement pseudocode standard. Just saying that the main thing I want to point out is that the then, many languages do not use the word then. This book uses it for clarity. Okay. All right, we're going to run through figure 4.3. It's an interactive program that computes the payroll for employees. Now, the program displays the weekly pay for each employee at the same hourly rate of $10 and assumes that there is no payroll deduction. Now, the mainline logic calls the housekeeping, the detailed loop, and the finish modules. The detailed loop module contains a typical dual alternative selection, and that determines whether an employee has worked more than. So you already know what sign you're going to be working with. More than a standard work week, which is 40 hours, and pays 1.5 times the employee's usual hourly rate for the hours worked on the excess of the $40 per week. Okay, so that's only for the $40 excess. So let's have a look. Let's run through the program. We have our declarations, string name. Remember, it's for each employee, so we need the employee's name. Hours. So we're going to work it as hourly rate, so we need hours. Then we've got our hourly rate, which is $10. Look, it's a named constant. Work week, also a named constant. 40 is our work week. Overtime is 1.5 times. And numpay, which is going to be our variable, which we're going to store the employee's pay within. And then we're going to have quit, ZZZ, because remember we're going to have a loop, so we need to exit the loop somehow, and so we're going to create a sentinel value of ZZZ when they're typing quit. So this will be our standard. We've got name does not equal quit, and we have our detailed loop, and it's going to carry on and on until ZZZ has been entered, and then we'll stop the program. So let's run through each of the modules. Housekeeping. Housekeeping said, okay, the program needs to output this program computes payroll based on. So we're just giving a bit of a preview of what our program's doing. We output overtime rate of overtime, which is 1.5 after work week, which is 40 hours. So we output enter employee name or quit to quit. So quit, that named constant, is calling on ZZZ. And then we're going to input our first name. So this is going to be our priming read. And then we return to our program and we start our detailed loop. So name is now being compared to quit. So we output enter hours worked and we input our hours. And names, if hours is greater than work week, which is 40, then pay is going to be work week, which is 40, plus times rate, plus hours minus work week times rate times overtime. And if hours is not greater than work week, then you're just going to have normal hours multiplied by rate. And then we're going to output pay for the name. And it's going to be our dollar. You see dollars within the quotation marks there, comma, pay. And then we're going to enter employee name, output enter employee name or quit to quit, and we input the next name. Okay, so here we input our priming read. Then we input the hours from our priming read, and then we're going to input our next name, and then we're going to carry on with the loop here. To finish, we just output overtime pay calculation complete. We're just ending our program in a more structured manner. Alright, let's compare our pseudocode with our flowcharts. If you have a look at the pseudocode, the declarations is the same as the declarations in the declaration square of our flowchart. If you have a look at housekeeping module, it calls on the housekeeping module, same in the pseudocode as it does in the flowchart without flowchart symbols. Then when you get to the while loop, you'll see it becomes the decision and the loop is a while, and you'll see the sentinel value, name not equal to quit, that goes next to our while, and then our detailed loop module goes within while and end while. So that is why it's indented over there. And then we get our finish module after our while loop has taken place and our program stops. Now when we call our housekeeping module goes to below our main program, which is between our start and a stop, and you'll see our housekeeping holds our 3 outputs as well as our input name, which is our primary read, and then we have return, which returns us back to the main program. Our detailed loop module, it's same, it holds our output, it holds our input for hours. It shows us the selection, our decision. So if hours is greater than work week, then we're going to do the extended calculation, our extended clause for pay. And then within our else clause, we'll do our more shorter calculation for pay. And then we end our if. Whenever we open an if, we have to end an if. Then we're going to output the text pay for and whatever stored in the variable name at that time, and output the text is dollar and whatever's in the paid variable. Then we're going to output the text to employee name or quit, ZZ, to quit, and then we input the next name, and the loop begins, carries on until ZZ has been inputted. Then we're going to finish with our output overtime pay calculation complete, and then return to the main statement. Within your if statement, if hours is greater than work week, so if hours is greater than 40, if that is true, then we're going to do the longer pay rate clause. Else, you're going to do the shorter pay rate clause for pay. So the if then clause holds the action or actions that execute when the tested condition in the decision is true, and the else clause executes only when the tested condition in the decision is false. Figure 4.4 shows a sample of the execution of the program in the command line environment. So this program computes payroll based on overtime rate of 1.5 after 40 hours, enter employee name or ZZ to quit, Wilson, enter hours worked, 39. Pay for Wilson is $390. So basically what's going to happen if we compare this to our program, we're executing the output of the overtime rate, and we output enter employee name ZZ and quit. So we enter Wilson. Wilson has been saved into the name variable, and then we go into name is being compared to quit, which is not the case. So there we enter our detailed loop, output enter hours worked 39. Pay for Wilson is how many? $390. How they work that out is they said, is 39 greater than 40? No, it is not. So pay is just 39 multiplied by our rate, which is $10 here, and we get $390. Enter employee name, and it's easy to quit. We enter Daphne. So we're entering Daphne now into the name variable, and we loop up, enter the hours worked for Daphne, 40. Pay for Daphne is 400, so they went hours multiplied by rate, 40 multiplied by rate, because hours is not greater than work week, 40 is not greater than work week, so therefore we just get the shorter pay. Whereas if we look at pen is now 41, 41 is greater than 40, therefore they will get more pay. So work week, which is going to be 40 multiplied by $10, plus hours minus that, which is 1 multiplied by the rate times overtime, so 10 multiplied by 1.5, so we get $415. Now we enter the employee name, we enter ZZZ, and we go straight to our finish output overtime pay. Calculations is complete. Please join me in the next video in which we'll be discussing the relational comparison operators.